More than 1 million students are taking admission in computer engineering every year. But only few thousand are getting placed in their dream companies. So what do you think? What is the reason behind this? Actually, this is all about consistency and step-by-step guided preparation. I'm happy to announce you that Ineuron is coming up with DSA Foundation course specially curated for product-based companies. So if you are targeting for Mang companies or any other product-based companies, please join this free course. For more detail, check out the description. The classes will start from 24 Jan, 5 p.m. Best of luck. Hello everyone, welcome back to the DSA Foundation course specially curated for product-based companies. So if you are targeting for Mang companies or any other product-based company, so this DSA series is going to help you people. My name is Puneet Kansal. I am the instructor for this complete course. So if you are new here, let me tell you, this session is the part of complete DSA series. So this is our 8th lecture. This is our 8th lecture. If you are new here, let me tell you, this already we have completed 7 lectures. Okay. So, but you do not need to worry. Okay. You don't need to worry because our every lecture is independent of each other. So today, what you need is nothing. You just join this session, and after the end of this session, you will start feeling comfortable with recursion, which is one of the most important topic in DSA, actually one of the most important topic in DSA. So I will try to build your base in recursion, and then we will solve one product based company problem also with the help of recursion. And okay, before further continuing, please write in the chat box if I'm properly audible and everything is properly visible. Hi Vikalp, nice to see you back. Please confirm me if the screen is visible and I'm properly audible. If any issue, please let me know. Please let me know if I'm properly audible or not. And meanwhile, okay, if you are replying, maybe you people are replying now. So meanwhile, thanks Nidhi for replying. Thanks Vinit. Fine, okay. So let me little bit tell you about this series first of all. Maybe there may be some people new here, so for them only. So this session is the part of complete DSA series of 18 sessions. We are going to cover all the most important topic of DSA in this series. Actually, we have already completed 7 lectures. We have already completed these 7 lectures up to bitwise operators. Today this is our 8th session in this series, and we will cover the recursion. We will build our foundation. We will build our base in recursion. And next week, okay, we will go with the sorting, searching, linked list, hashing, stack, queue, and then further, okay, graph, greedy, and dynamic. So we will cover all the important topic in DSA in this series. So what is the benefit of this series? After completion of this series, you will start feeling comfortable. You will not get fear, at least from the DSA. You will start feeling, okay, it's not that much tough. It's not that much tough. It's interesting even. And one more thing, you will start feeling like product-based companies problems, Mang company problem are not that much tough. They are achievable. We can break that. We can break Mang companies. That is not a big task. After completion of this series, this is my motive actually, to make you feel like, okay, DSA is not that tough. And that is not tough, because this is all logical. And we human beings are good at logic building. Little need practice. Okay, that is the only thing needed. So in this series, I'm going to build your foundation, DSA foundation. I'm covering everything from very basic, and also I'm covering product-based company problems, so that I can make you feel that, okay, you start believing yourself. You start believing yourself that, okay, these problems are not that much tough. Product-based companies, Mang company problems are not that much tough. If we will do little practice, we can also break that. We can also go over there. Okay, so I just want to build that belief in you people with the help of this series actually. Okay, fine. And okay, one last thing from my side, who will get benefited from this series? So who are beginner, they are welcome, because I'm in every lecture I'm starting from definition. I will today also start with the definition of recursion. Okay, so if you are a beginner, if you are even in first year, even you are in school, you are welcome here. Okay, because everything is logical. I will tell you the thing, then we will use it, that's it. So if you are a beginner, you are welcome. If you are advanced learner, still you are welcome. Why? Because we are covering product based company problems. If you have attended my previous lecture, you have seen that, okay, we have covered the product based company problem in all the sessions, actually, wherever that was required. And third type of person who can get benefited from this course is who are right now in service based company and they want to change their life, they want to change to product based company. So again, this course will help you. So okay, fine. Yeah, good evening, Karthik, nice to see you back. Thomas, clearly audible. Divyanshu, thanks for replying. Vikal, please tell us about the recession of companies and why companies is not hiring nowadays. So it's according to me, actually, I don't want to speak it more about it, but still, okay, this is trending topic right now. Uh, okay, according to me, it's my opinion that, okay, it's the era of now AI. Okay, it's my personal opinion. Okay, it's not about what I believe. It's not about the performance, why they are firing. It's about I think it's about they are making a transition into AI era. Actually, they want to transition into AI era. Okay, and if they will not make this transition, then they will not survive in market. They will be obsolete, actually. Okay, and this is their requirement. I don't want to blame them. It's so yeah, I know that it's really tough for the people to get a new after getting fired. It's really going to be tough because they have their families, and yeah, that is bad thing. But companies also don't have choice. They need to transit to AI technologies, and for that they are making their new teams from Google to everyone. Okay, if they will not transition, then they will not survive, they will not compete. Okay, so they also know that, okay, their impression is going very bad in the market. They have very good name. These companies have very good name in market, still they are firing. They know that that will impact their image, but they also don't have choice, actually. Okay, so it's a part of life, I can say. Okay, they are also in problem, companies, and due to that, okay, we people are also facing the problem. Yes, so it's what I believe, it's mainly due to AI. Okay, okay, so people who are in AI, they can laugh and they can enjoy. Okay, because again, according to me, as I'm also a researcher in AI, according to me, next decade is going to belong to AI only. There will be no website who will not be using the AI. If there will be any website, then nobody will use that. People will say that the people will itself will say that, okay, how silly this website is. The intelligence should be there in the website. Otherwise, okay. Otherwise, people itself will throw that company out. Okay. Okay, Vikalp, you guide will too much help in my career. Okay, that's great to listen that. Okay, if my guidance is helping you people. Okay, let me take one or more two questions. Otherwise, we will move to our topic, recursion. Let me take one or two question because it's really important. The question you ask. What will I do best in my career? Please guide me. Vikalp, it's okay. I will not guide you personally, but I will say one thing to everyone that, okay, see, you just build one skill. You need to build skill. Okay, degree will not help you. Any degree, if you are taking any degree you are taking, that will not help you in the future. What will help you? What will help you to survive? It's not about only entering inside the industry. after entering, you if you will survive only if you will be having the skill. Okay, that is the only way to survive, that is the only way to growth, and that is the only way to be happy. That is the only way to be happy. Believe me, you cannot survive for long if you don't have skill. And even though you will survive, you will not be happy, because you will keep protecting yourself every time, you will keep hiding yourself, and you will not be happy. Okay, so please choose one line. Okay, choose one line. Everyone, please choose one line. Which line? Which line, sir? Whichever you like. Whichever you like. It's okay. You are zero at it. It's okay. If you are zero right now, today you are zero at it. If something is fascinating you, if something if there is something for which you can work for whole night, if there is something company is not asking but you want to work, it's that is coming from inside, that okay, I can spend my life while coding, I can spend my life like this. Please choose that. It's, you may be finding that okay, I'm talking bookish language. This is what I have seen in my own life also. I'm sharing that only. I'm sharing that only. If you, whatever is that, whatever area, AI you want to go, or simply competitive programming, through competitive programming you want to go, or whatever area you want to go, choose that line. Maybe today you are at zero, confirm after 2 years you will be very good at that, because you are not looking at the time now. You are not looking at the time. You are not looking at the time, how much this is in the midnight while working on that thing, because you like that. And believe me, nobody can compete with you also. Then nobody will be able to compete with you also. Okay, so choose the line, whichever you like. Maybe today you are at zero, don't worry. Believe me, if you really like it, then you will not see the time. And if you are not seeing the time, automatically you will be master in that. And when you will master, there will be your demand. Whatever recession is coming, no, whatever is happening, you will definitely survive. If nothing will happen, you can open your own business. You can open your own business. People will hire you. People will hire you. They want quality. That's it. They want quality. Even you also want quality. Even you also want quality in my lectures. If I will not provide, you will not spend time over here. You will not come back. You are coming from last 7 lectures. Let me praise myself. You are coming from last 7 lectures because you are finding something over here. If I will not deliver, you will not come. Why you will waste your time over here? Everyone want quality. Just choose your line, whichever you like, because in that you will put the full effort. Without, you will not work for the company, then you will work for yourself. And when you will start working for yourself, nobody can replace you, and you will be happy. The most important thing is that you will enjoy the things. You will start feeling happy. Your life will be happy. Okay, that's it from my side. Otherwise, I can spend my whole lecture. I'm a teacher. I'm sorry. I can take next 2 hours to speak on this. Okay, fine. So let's start with today's topic now. Let's come back to today's topic. That is recursion. We will talk about recursion, which is one of the most important topic in DSA. Okay. So I will try that. Okay, you feel comfortable. After this session, you will start feeling comfortable with the recursion. Even you are a beginner, you will start. I will try that. Okay, you will start feeling comfortable. If you are advanced learner, I will come up with the product-based company problem. There you can apply your knowledge. Fine. Okay, fine. So let's start with the recursion. Okay, let's start with the recursion. And let me share one code with you people. Let me share one code with you people. Okay, this is the code. Can you tell me, okay, can you tell me what is the function of this code? Please try. That is the requirement. That is the only prerequisite we need. What is the prerequisite for these sessions? You need to think. You need to think. You need to think, and you need to reply. That is the only thing required. Please check out the code. Just take it as a pseudo code, okay, and think it like a pseudo code, and try to find out, okay, what this code is doing. So this is the driver code, and we are calling a function fun. what this function fun is doing. What will be the output? What will be the output? It will not be 120. This will not be 120. This will not be 120. We are not finding the factorial. We are not finding the factorial. Please check out carefully. Please check out carefully. Please check out carefully. Karthik is saying, okay, please everyone check out. Everyone, please verify. You need to think. Otherwise, there is no way to impart DSA in you people. I will keep talking. I will keep giving the solution. That will not work until unless you will not think and reply. Please think and reply. Whatever is the answer, doesn't matter right or wrong. Immediately you will think. Immediately you will reply. Learning will happen. Learning will happen, and you can dance. You can dance that, okay, learning happens. Doesn't matter at all whether that is right or wrong. Yes, Praveen. Great to see. Aman, great. So let me execute it. Let me execute this code and see what this code is doing. So here I'm executing the code. It's printing 1 to 5. It's not printing 5 to 1. It's printing 1, 2, 3, 4, 5. It's printing 1, 2, 3, 4, 5. It's printing 1, 2, 3, 4, 5. It's not printing 5, 4, 3, 2, 1. Durga Prasad says it's printing 1, 2, 3, 4, 5. Why it's printing 1, 2, 3, 4, 5? Okay, let's see that. Let's see that thing. Okay, fine. Let's see that thing. Let's see how recursion works. It's a very basic example. Okay. Even you don't know, you will understand everything. Okay. So first of all, okay, what is recursion? One line only. What is recursion? If there is a function, let me erase it once. If there is a function which is calling to itself from inside, from inside its body, the same function, fun function, I'm calling to itself. So this is recursion. That's it. This concept is they give the name recursion. That's it. So if a function is calling to itself, the function is calling to itself, that is recursion. That's it. So the same function will execute again, but with the different parameter. Parameter should be different. Otherwise, we will get stuck in infinite loop. Parameter should be different. Okay, fine. So we know recursion. A function is calling to itself. That's it. Now let's see how this function is getting work. So here we are calling the first time this function fun. And after that, okay, what is happening? Let's suppose, okay, here n value is 5. Here n value is 5. We are passing 5. N value is 5. N value is 5. N is, okay, we are calling the function fun. Let's see how this is executing. We are calling the function fun with value 5. N is not 0. N is not 0. So we come in the else part. And then we call this function again. We call this fun function again. We call this fun function again. So let me call it once again. But this time, n minus 1 with n minus 1 value. 5 minus 1, 4 value. We call it again. We call it again. But this time with 4 value. This time with 4 value. Okay, let me call this code again. 4 is not 0, 4 is not 0, n is not 0. So we come to the else part. Again we call the function, but one less value. 4 minus 1, n minus 1, 3. With 3 we call this function. Okay, again now we call the function with 3 value. So now this time again n is not 0, 3 is not 0. We come to the else part, and this time we call with 2. Then we will call with 1. The same function, fun, and after that, okay, we will, so this is 0. Okay, this will go up to fun 0. We will pass 0. When we will call with 0, okay, 3, 2, 1, 0. When we will pass 0, then this condition will satisfy and we will return back. We will return back. Fine, we return here. After coming here, we were here actually when we were executing this code. After that, one more line of code is there that will also execute. This will also execute. This is printing the number. What this is doing? Printing the number. And what is the n value right now? 1. So this print 1. After printing 1, this go back to previous function. And this function will also print the value. Which value? This value. 2 value this will print. And this will go back and this will print this 3 value, and this will go back, this will print this value 4 value, and this will go back, this will print 5, and this will go back, and this will end. So what we are printing first? 1. We print this first, then this, then this, then this, then this. So 1, 2, 3, 4, 5. So we print 1 to 5. We print 1 to 5. Fine. One thing is, okay, we are saying that, okay, how the function is calling to itself, how the function is calling to itself. We start printing from 1 to 5. Okay, 1 to 5, 1 to 5. Fine. Let me add one more thing over here. And even before adding that thing, can you modify this code? Can you modify this code? Some people were saying this will print 5, 4, 3, 2, 1. Can you modify this code somehow? Can you modify this code so that this start printing 5, 4, 3, 2, 1? Can you modify this code? Can you tell me what we need to do? Hello, hi, good evening, Mandip. Nice to see you back. Can you please try this? Here is one code. Here is one code. Can you please somehow, can you try to modify this code so that right now this is printing 1, 2, 3, 4, 5. I just want that this should print 5, 4, 3, 2, 1. Can you modify, can you think, okay, how we can modify this code? Shivam says yes. Shivam, can you please let me know how you will do that? How you will do that? And Vikalp, okay, you might be thinking. Fine, okay, already given the answer. So I'm taking that right now. Okay, that's great. People, everyone is replying. Manikanta, Jayashri, everyone is there. Durga Prasad, that's great to see. That's great to see. So, oh, okay, you people are saying that, okay, so, like Karthik and Vikalp are saying that, and other people are saying that, okay, shift this line, shift this statement over here. That's it. Fun, move the fun after this. Move the fun after this. Okay, let me do it. Let me do it and then let's check out. Let me clear this and let me modify the code. So I'm just Control X and Control V. That's it. They are saying this thing to asking me to do this thing. So okay, let me do it and let me run the code. And okay, let me erase it first and then run. So output is yes, 5, 4, 3, 2, 1. Output is 5, 4, 3, 2, 1. Yes, you are right. We have printed 5, 4, 3, 2, 1. Great. So let's see how this all is happening. And I will add more concepts in it then. So first let's see how this is happening. Otherwise already we know that if n value is 5, then we will call the function for 5. And then this is not 0, then we will come here, then we will print first. First we are printing. First we are printing a 5, then we are calling the function. Then we are calling the first printing, then calling this time. So 5 will be printed first, then we will call the function fun with 4 value, then we print 4, then we will call the function with 1 less value, n minus 1, then we print it and call it, print it and call it. So let me keep printing it and keep calling it. Keep printing it, keep calling it. When that will be at 0, so that then we will return. Then we will return from here itself. Then we will return from here itself. So first we print this, then this, then this, then this, then this. So we print from 5, 4, 3, 2, 1. Yes, yes, we print from 5, 4, 3, 2, 1. Fine, okay, fine, fine. Now, can you people tell me? Can you people tell me? Please keep thinking, keep replying. That is the learning part only. Can you people tell me what is the time complexity? What is the time complexity for this code? If anybody can tell me, what is the time complexity? What is the time complexity for this code? Keep replying. Yes, Sarah, please reply. Bharat, welcome back. These people are coming to every lecture. Jayashree, Bharat, all these people. Great. My promise, you will start feeling good in DSA. The phobia of DSA will go away. That will go away. That is my promise. Okay, the time complexity. shared by maximum people is order of n, because how many time we call this function? See, 1 2 3 4 5 time. Okay, you can say one more time. So you can say, okay, n plus 1, n value is 5, so you can say, okay, n plus 1, you are calling this function. So this is the time complexity, or 1 is constant, you can say order of n, yes, order of n is the time complexity of this code. Another question, what is the space complexity? Okay, what is the space complexity for this code? If anybody can tell me. Keep thinking, keep replying, that is important. Right or wrong doesn't matter at all. You know that doesn't matter at all. Immediately you reply, learning happens, that's it. And we can dance, immediately we can dance also. So keep replying, please. What is the space complexity? What is the space complexity? Doesn't matter, right or wrong, doesn't matter. So, okay, here Mohan is the new guy who is telling the right answer. And our Thomas and our Mandeep is also here, who is fighting. Fine, the space complexity is actually order of n here. How that is order of n? Okay, fine, let's see. So if we see that, okay, what is the space complexity? We know that space complexity is nothing, just input space plus auxiliary space. Auxiliary space means extra space taken. So how much space taken by input? Input is just a number, integer. So constant, you can say, okay, 4 byte only. Integer, that is integer, so 4 byte. Plus, what is auxiliary space here? See, although I have not used any other variable over here, but in recursion, whenever we use the recursion, this is important. Whenever, every time, whenever we use the recursion, there will be a stack. A stack will be generated into the memory. That is maintained by the CPU. So this is a stack. So this stack is having the information of the functions. So first you are calling this function, then you leave this function in the middle and you call the another function. You leave this function in the middle, you call the another function. You leave this function in the middle, you call the another function, and so on. But you need to complete these functions. So you are whenever you are coming back, this function should be there. And we must have information that, okay, we have executed up to here. We have executed up to this statement. So all these previous functions, like function 1, fun 5, fun 4, fun 3, fun 2, and fun 1, all these functions will be stored in memory in the form of stack. They will be stored in the stack by the CPU. CPU is maintaining this information because we need them back. Whenever we will roll back, we need to roll back the recursion. When we will roll back, we will be needing all these functions. In which order? First this, then this, then this, then this, then this. So in the form, so that's why they are stored in the stack, because stack use the principle of last in, first out. Okay, so don't need to worry about the stack. We will cover the stack. But right now you need to know just one thing. What is that thing? Whenever we use the recursion, the CPU maintained a stack. Stack of what? Stack of previous called functions. Information about them will be stored into the stack, because we need that information again. We need to come back to these functions again. So as a programmer, we do not need to worry. Who will worry? This person will worry. CPU. He will cry. The CPU will start crying. Immediately you will use the recursion, CPU will cry, because he need to maintain all the previous information. He need to maintain in the stack. But programmer will laugh. He will laugh that, okay, this is looking, why programmer will laugh? Because if you will write using the recursion, then if new programmer is coming in the company, he will be very happy, because this code will be very easy for him to understand. because this code is doing the same thing again and again, same thing again and again. So this code will be very easy for new programmers to understand. And this is very important actually. This is very important that, okay, this is actually, I will say that, okay, 80% of the company expenses goes on maintaining the software, not developing the software. Developing the software take 20%. 80% is taken to maintain that software, okay, to maintain it, okay. In the maintenance goes 80% money. So if Recursion is helping to maintain the software in better way, next person who is coming, who is going to check out your code, improve your code, he or she can understand the code better if you are using Recursion. So that's why, that is the reason actually why companies prefer that, okay, you write the code in Recursion, because that is easy to understand by the programmer. That is easy to understand by the programmer. That might be tough for the CPU. It's okay. That is his duty to maintain this stack. But stack is maintained. Because this stack is maintained, what is the size of the stack? 1, 2, 3, 4, 5. So n value is 5. So the stack of the stack space is n. So auxiliary space means extra space is n. Total space is n plus constant, that is n. So space complexity here is constant. Space complexity here is constant. Sorry. Space complexity here is n. Space complexity here is n due to this extra space taken by the CPU to maintain the previous functions. Fine. Okay. Okay, fine. Fine, okay. I will add more thing. Don't worry, I will add more thing in this. Okay. Can you? Okay, let me give you one thing. Can you? Okay, I'm coming to your questions first. Answer this question first. I'm coming to your questions first. Answer this question. I want to modify this code. And I want to write a program. Okay, for finding the, just a minute. Okay, finding the sum of, and right now we are printing, okay, 5, 4, 3, 2, 1. In this case, we are printing 5, 4, 3, 2, 1. Can you modify this code so that we get the sum of 5, 4, 3, 2, 1? Can you sum this code and sum these elements and give me the sum back? Can you modify this code somehow and give me this sum? Okay, take this question, and meanwhile I'm coming to your questions. Okay, let me take one question of my interest first. Okay, Satish is asking, sir, please tell me if there is a paid course for DSA, as I am interested to learn in depth. So yes, there will be after this series actually, there will be an advanced DSA course. In which we will start from again basic, but we will go to the product-based companies. Okay, and we will cover each and every concept in that. That will take time also, near about 4 months to complete. And yes, you can check out it on Ineuron website. Yeah, there one course is available, which is in depth, starting from very basic, going till very advanced, and you can check it on Ineuron website. Okay. So another question, okay, I'm taking. Nivedita is asking how we can access the previous 7 lectures. So you can find the link in the description of this video. If you are watching on YouTube, then you will find out in the description of in the description there's a link of this complete course. Go to the course, click on the link, and you can register for this course. This course is of 0 cost. Okay, the price is 0 for this complete course. So you can then access the 7 lectures also, previous 7 lectures also, as well as you will be getting the certificate. If you are completing all the videos, then you will get certificate also. Sarah is asking, do you recommend using recursion in the interviews? Yes, I will recommend to use the recursion in interview, because recursion is actually helping to improve the code actually. Okay, understanding of the code, understanding. Okay, we will talk more about it. Recursion, using recursion doesn't mean that, okay, some people think that using recursion means you are reducing the time complexity. No, you using recursion, even you increase the time complexity. Space complexity you have already seen. We are taking extra space. If I will ask you to print the number, if I will ask you to print the number from 1 to 5, you simply will write a loop. You simply will write a loop up to 5. Okay, and you will just see out. That's it. So you are not using any extra space over here to print the number from 1 to 5. But whenever you are using recursion to print the number from 1 to 5, you are using extra space also. This is also time complexity is same. Okay, this is also order of n time if n is here. Okay, so this is also taking order of n time to print the number 1 to 5 or 1 to n. But this is taking constant space. This is taking constant space. Okay, then why I'm saying you that, okay, why I'm not saying that use this one? Why I'm not saying use this one? Why I'm saying use recursion? Because might be, okay, this is right now looking easier to you people, but for the more tougher concepts, this will be better to use the recursion. You will find yourself, in the case of, mainly in the case of dynamic programming, while solving the problems, you will find out that, okay, using the recursion is very intuitive. That is very intuitive. Okay, rather than using the loops. Okay, so why they, even though this can take more space, confirm this will take extra space. This is not taking extra space. Still, they are ready to compromise on the space. Companies are ready to compromise on the space because they want more clarity in the code. Because 80% their money is going on maintenance, and they want that, okay, in the next programmer who are joining the company, he must be able to understand the code easily. Okay, he must be able to understand the code easily. I have seen the people who are get fired because they are not doing documentation, and they are not using proper variable names. They are getting fired from the company. Okay, so can you please tell me what? So, okay, can you convert this code into sum? Can you sum the element? Okay, so let me see if there are some answers over here, like so, okay, one of the answer is that, from the last answer I'm picking from Abhishek. Let me show you people what is shown by Abhishek. I'm taking that answer actually. Abhishek is saying that, sir, replace this statement with the, let me copy his statement, sum equal to sum plus n. That's it. He's asking me to replace this statement with this statement. That's it. And actually, one more thing, Abhishek, you need to do, if you are doing this thing, then you need to declare the sum variable as a global variable. You need to declare the sum variable as a global variable, because otherwise every time you will update this variable, that should be global variable. Okay, you are storing the value into the global variable, then you can get the final results. Okay, let me try to code this this solution, which is given by the Abhishek. So let me try to modify the code according to that. So let me bend my laptop a little bit. And so what we need to do, okay, let's take a first global variable over here, according sum equal to 0. And he is asking us to replace this cout statement with the sum statement. Okay, so sum, he is asking that sum equal to sum plus n. Okay, and one more thing we need to do actually here is that we need to return 0. If n value is 0, we need to return 0. That's it. And okay, at the end we can print the value also. We can see out. We can print the sum value at the end so that we can see the result. Fine, done. So let me execute this code. So okay, so this is actually returning the value. So this should be integer over here. What is the mistake we are making over here? Okay, let me run it again. Let's see, check out. Control reach out of the function. You can also let me know, return sum in function. Okay. Okay, we are updating here right now. We are just trying to use this one. Yes, we can return Vikal, but right now, okay, we are taking is at a global variable, and what is needed over here? Just a minute. So return 0 and 0 and sum equal to sum plus and 1 and minus 1. It's working fine. What's the problem? So let me clean this and let me see it. Which is end of non-void function. It's showing 15. Result is showing 15. But only some warning is coming. Okay, it's okay. We will see it. What warning is coming? But okay, the result is coming 15. We are getting our 15. We are getting our sum. We are adding the number from 1 to 5, and we are getting 15 over here. Okay. Just a minute. Let me see what is over here. Fine. Okay. So here what we are doing is we are just summing the number. The thing is here is that, okay, the thing here is that we are taking a global variable. We are taking a global variable, and we are summing in that. That's it. We are again calling it again this function again and again, and after that, okay, we just coming back from this function, we are printing that number. That's it. This is what we are doing. But this is not the best practice actually. That's why many people are saying that simply they are not happy with this code, and the reason is that, okay, the one reason is that it's not a good idea to use the global variable. It's not a good idea to use the global variable. You should not use the global variable. You have to minimize this thing. This is not a good practice. So any other answer in which we are not using the global variable? Okay, we were using global variable. The answer is working fine, but it's not a good practice actually to use the global variable. So what other thing we can do? Anybody? What other thing we can do? So okay, let me write over here. What some people are writing, simply return. Like I'm taking from the Karthik. What we can do is we can return. We can write, okay, return n plus. We are adding it and calling the function again. 1 and minus 1 and minus 1. Okay. So now that's it. What we are doing, we are just adding the number immediately and calling the function further. We are calling the function further. And let's see if this will work or not. This will work or not. Okay, let me see out the fun function also. See out whatever value we will receive from here, we will print that value. Fine. Okay, let's execute this code now and let's see if this is working fine or not. Let me erase everything first, then we will execute. What is the problem? Nothing. Problem why it's showing. Yeah, nothing is the problem. So let me execute it again. Yeah, it's showing 15. So it's working fine. Okay, it's working fine. So there is, I think, problem with some this compiler also. Fine. Okay. So this is another way. Okay, this is another way. We are summing the numbers. We are summing the numbers. Okay, we are summing from 1 to we are summing all the number 5 plus 4 plus 3 to 1. Okay, we are summing like 5 plus 4 plus 3 plus 2 plus 1, and after that, okay, even you are summing 0 also. You are getting 0 return from here, and you are summing that also, and then after that you are returning all that stuff back to our main function from where we call this function, and that's it. Okay, we are summing the number, and we are executing this code. Okay, fine. Okay, till now everything is fine. We are just summing the number. Okay, fine. Another question from my side. Can you modify this code again? Can you modify this code? Can you modify this code to print the factorial of a number? Can you find the factorial of a number? Yes, yes, Durga Prasad, we use your code only. That is. Can you change this code to find the factorial? Somebody can tell me. Okay, can you change this code to find the factorial? And anybody, can you change this variable to find the factorial? What is factorial? Okay, let me, if you don't know factorial, factorial of 5 is what? What is the factorial of 5? Factorial of 5 is what? So that is 5 into 4 into 3 into 2 into 1. So that is actually, that will be 120. 120 should be the answer. 120 should be the answer. So we need to, can you change it? Okay, we get one answer from Shivam also, from Abhishek also, from okay, Aman also helping us by, Aman is saying that replace this 0 to 1, replace this 0 to 1, otherwise everything will become 0. And other people are saying that replace this plus with the multiply. Replace this plus with the multiply, because earlier we were just adding the numbers. We were doing 5 plus 4 plus 3 plus 2 plus 1. This time you need to multiply, so multiply it. And Aman is saying that don't write 0 here, otherwise this will give 0 answer. This will give 0 answer. So we are getting 0 over here, because at the end we are multiplying with 0. So Aman is saying that replace this 0 also with 1. Replace this 0 also with 1, so that we can get 120. So that we can get 120. Okay, fine. Okay. So we're just trying to code some basic things using recursion. The motive is that, okay, you need to know, okay, how recursion is working. Okay, how recursion is working. One more time, okay, let me execute this. One more time, I'm going to execute this on the board. So the people who are looking it first time, so for them only. So first time we are calling this fun function with the value 5. And after that, okay, this value is not 0. So we are coming to the else part, and we are calling this function n into factorial of 1 of 4. So again we are calling, okay, this n is 5 actually. This n is 5. 5 into this, then 4 into fun of 3 this is how this function is calling again and again to itself. Fun of 2, fun of 1. Okay, and even you can write 1 over here, and you can return from here itself 1. So okay, and then when this will return 1, 1 into 2, 2 into 3, 3 into 4, 4 into 5. So you will get 120. So this is how recursion is working. This is how recursion is working. Okay, so now we are good at the basics now. I hope we are good at the basics. At this, okay, let's wind up this. Can you tell me what is the time complexity also? Time complexity of this code. If anybody can help me to find the time complexity. What is the time complexity of this code? How much time this is taking? How much time this is taking? Anybody? Order of n. Bharat is saying order of n. Okay, how much space this is taking? How much space this is taking? Okay, once again, earlier the people were replying wrong. So let's see if you are now checking the space complexity right way. How much space this is taking? Space. Time is order of n. Yes, you are right, because you are calling 5 functions. Factorial of 5, factorial of 4, factorial of 3, 2, 1. So 5 times you are calling the function. So time complexity is 5. And what is the space complexity? That is again order of n. The space complexity is again n, because 5 functions will go inside the stack. 5 functions will go inside the stack. So the space complexity will be order of n. And this is done by the CPU. This is done by the CPU. We do not need to worry about it. So this is done by the CPU. Okay. One last thing, okay, I can ask you, okay, maximum one thing I can more ask you. Can you tell me the recurrence relation? The people who joined the second lecture or third lecture, okay, asymptotic notation 1. So in that we talked about, okay, can you tell me the recurrence relation of this? Anybody? Anybody if can tell me, then we will move on. That's it. Recurrence relation. So if you can, okay, how to find the recurrence relation? If you remember, so write it as a Tn, and this is Tn minus 1. And what other operation we are performing? This is constant actually. This is constant. So what is the recurrence relation? This Tn. So more, and then this Tn minus 1 plus constant. That's it. This is the recurrence relation. And if you will solve it, then again you will find out the time complexity is order of n. The time complexity is order of n. Yes, Thomas, you are right. Yes, Vikalp. Vikalp is not. Yes, that's why I was asking actually. This will not be into n. This will not be. This is not. No. This will not be into n. See here. This is the. That's why I asked this question actually. Here, this is just one operation. We are not doing n operations. What we write over here, if you remember from the third lecture, what we write here, how much time more is taken. This is just one operation, multiplication operation. It's not like we are multiplying n times. It's not like we are multiplying with one number. Okay, so it's a constant time. This will take constant time. So this will not be into n. This will be plus 1 only. Okay, this will be plus 1 only. Fine. That's why actually I ask you. And if you will find the recurrence relation for previous problems also, that is same. This is the recurrence relation for all the recursive programs which we have discussed. Printing 1 to 5, 5 to 1, summing the numbers. All recurrence relation is this, and that's why the complexity is also order of n. Fine, okay, if you don't know recurrence relation, it's okay. If you want to study this in more detail, you can check out the third lecture if you have not attempted. Otherwise, okay, it's okay. Now let's move on. Let me share my PPT back. Now, okay, let's start with the recursion now. So now we have little bit base. So again, I'm starting from very basic. The definition. I want to add some points actually. I want to add some points in the recursion. So, okay, let's see the definition first. The process, what is the recursion? The process in which a function is calling to itself. If a function is calling to itself, directly or indirectly, then that is known as recursion. But okay, directly we know that if this is a function, and if from inside you are calling another function, same function means you are calling again. So this is direct recursion. But if function 1 is calling to function 2 and function 2 is calling to again function 1, you can write like this: function 1 is calling to function 2 and function 2 is again calling to function 1, again calling to function 1. So this is indirect recursion. This is still recursion. This is still recursion. So either that is indirect or that is direct. That process, when a function call itself directly or indirectly, that is known as recursion. Okay, one point we'll learn from here. Let me add some more important point about the recursion. Another important point, okay, another important point is that whenever you are calling the function, whenever you, this is the pseudocode for finding the factorial. Okay, we already discussed this thing. So whenever you are declaring the function, so one thing is always required. What is that? Termination condition. What is that? Termination condition. Termination condition will always be there. Termination condition will always be there. What will happen? Okay, let's suppose if termination condition is not there, or you can say that, okay, base condition. Yes, Karthik, you can say that, and Mandeep is saying that otherwise you will get stuck into infinite loop. If termination condition is not there, we will get stuck into infinite loop. Okay, we added this point. One more point I want to add. Whenever you are calling a function from inside, the parameter should be changed. This parameter will be different. See, here we have n, here we have n minus 1. Number of parameter will be same. Number of parameter, how many parameter we are passing? One parameter. But the value, I'm talking about the value of this parameter should be changed. Okay, fine. So this is the another point. Another point, okay, we have already discussed actually, and that this is that and the point is that why we use the recursion. So okay, this thing, okay, I can add at least. When we use the recursion, when we can break the big problems into smaller problems. When you feel that, okay, to find the factorial of 5, what you need? You need to know the factorial of 4. Okay, and what you need to do? You need to just multiply that with the 5. Whatever is the factorial of 4, you need to multiply that with the 5. And to find the, okay, you might be thinking that, okay, you might be feeling maybe factorial of 4 is bigger number. So what you need to do to find the factorial of 4? This is the big problem. So you can break it into smaller problem. So 3 factorial into 4. If still you are thinking that, okay, finding 3 factorial is big, then you can say that, okay, let me first find the factorial of 2 and then I can find it easily. If you are thinking, okay, finding factorial of 2 is also big, then okay, you can say that, okay, give me, I know only the factorial of 1. So that will be 1. And after that, I can solve it upward. So whenever we have big problem and we can break it into smaller problem, then we can apply the recursion. So this is the one example I have given you. Another point. So let me add another point. Okay, this we have already discussed. Recursion is easy to understand by the programmers. So might be if you are using it first time, you might be feeling difficult, but this is really, if you will become used to the recursion, then this you will find it easy. So easier to understand by the programmer, although difficult for the CPU. CPU will cry because he need to maintain all the previous function inside a stack. Programmer do not need to maintain the previous function, and it's easier to understand the code if that is written in the form of recursion. Fine. These are some basic points about the recursion which I want to cover. These are basic points. If any doubt, you can ask me. Yes, Karthik, you are right. Tower of Hanoi is one of the means popular example of recursion based problems. Fine, okay. Okay, let's move on. Can you people tell me what is the function of this code? What is the function of this code? Keep trying, keep replying, please. Keep trying, keep replying. I will keep adding more and more information. Keep trying, keep replying, please. What is the function of this code? Check out. So there are two type of functions only we know. One is fun, one is foo. These are the only function we find out in our codes actually. So this is foo function. So what is the function of, check out everyone please. Everyone please check out what is the function of this code. Try to find out. Yes, Vikalp, I know you know, it's okay. Control yourself. Yeah, it's finding the Fibonacci series. We are finding the Fibonacci series. Okay, for the people who don't know Fibonacci series what? 0, 1, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 13 plus 8 is 21, and so on. We will keep taking the previous two numbers, keep adding them and generating the next number. Taking two numbers, adding them, generating next number, so on. So this is Fibonacci series. Fibonacci series is actually is very famous series. Actually, this is the series in our this is a series of life. This is a series of our life. Okay, this is how this is how life grow. Like if you will see a flower, then either you will find out one petal, you will find out three petals like this. This will be like flower will look like this, and after three petals, okay, there will be 5 petals outside. 1, 2, 3, 4, 5. 5 petals will be there. Like after 3, 5, and after 5, there will not be 6, 7. There will be 8 petals. You can check out. You can check out after taking any flower. You can see that okay, this is the series of life. Even our body also grow the same way. You can check out on internet, like our body is also the same. Like you can see our bones of this finger bones. So this is smaller one, and and after that, okay, this is little bigger and this is little bigger. So our bodies also actually grow like a Fibonacci series. Okay, fine. Okay, we were talking about the Fibonacci series where I went away. Okay, fine. So this is the program. Yes, you are right. We are finding the Fibonacci series. Not Fibonacci series actually. We are finding the nth Fibonacci number. Nth Fibonacci number. So okay, 0, 1, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 3, 13, and so on, and 21, and so on. So let me give the numbering also. So this is 0th Fibonacci number, this is 1th, this is 2nd, this is 3rd Fibonacci number, 3rd, this is 4th, this is 5th, this is 6th, this is 7th, this is 8th. So if you are asking, okay, what is the 5th Fibonacci number? So this will return the 5th Fibonacci number actually. This will calculate the 5th Fibonacci number, and 5th Fibonacci number is 5 actually. Okay, so how this is finding the 5th Fibonacci number? Let's see that. Okay, this is actually this is a multiple recursion. One recursion is here, one recursion is here. We are calling this function 2 times. One is here, one is here. So this is multiple recursion is here happening here. So how this is working? Okay, so let me show how this is working. This foo function is, let's suppose, calling for n value 5. Then This will call these two functions. One is this, one is this. So this is n minus 1 over here. I'm just showing that, okay, how recursion is calling, how recursion is calling. Okay. So here that will be, here is 5, then n minus 1 is 4. And here this is actually n minus 2, that is 3. And here this is actually 4 minus 1 is 3, 4 minus 2 is 2. Let me write foo. 2. Let me complete it now faster way. So this is, okay, I'm writing f only so that I can space some space also here. So left side I'm subtracting 1 and right side I'm subtracting 2. 3 minus 2 is 1. This one, this function is called, and this will be 1 and 1, and this will be 1 and 1. These are the functions we are calling actually. Okay, this will not be called up because whenever we will get 1, we will return. Fine. This will also be called f1 and f1. That's it. So actually, so these functions will be called, and whenever we will get f1, foo1, then this will return actually the same value, 1. So this is returning 1, this is also returning 1, and we are adding them. 1 plus 1 is 2, we get 2 over here. Here we have 1 because this is the function of 1. For 1 we are getting the same value, 1, and after that we are just adding them here, left and right. 2 plus 1 is 3, we get. For this function we get 1, for this function we get 1. 1 plus 1 is 2, we get over here. 3 plus 2 is 5, we get over here. For the fourth one, for a 3 one, for the third one, okay, 4 and 3, 4 and 2. Okay, let me do it. So this is 1, this is 1, this is 1 plus 1, 2, this is 1 plus 2, 3. Okay, fine, and this is actually 8. Okay, this is counting start from here actually. So this will be the fifth one. This 8 will be the fifth one. Okay, so this is returning 8 actually. This is returning 8. So function of what is the fifth Fibonacci number? That is 8. So this is how we are executing the recursion. How we are executing the recursion and how this function is called. That's just to show you, okay, how multiple recursion is working. That's it. Okay, fine. Just want to show you how multiple recursion is working. Now, okay, let me take one good question now. One good question let me take. This is the interview question actually. This is the interview question. So here we have already seen that, okay, we are finding the Fibonacci. We are finding the Fibonacci of a number. Okay. Here also we are finding the Fibonacci. See carefully what we are doing. We are finding the Fibonacci. What we are doing, we are taking previous two numbers and we are adding them, and then we are moving on. So it's like we are adding the previous number and iteratively we are finding the Fibonacci. Iteratively we are finding the Fibonacci actually. Nth Fibonacci number. Here also we are finding nth Fibonacci number. Here also we are finding nth Fibonacci number. Okay. Both sides we are finding the nth Fibonacci number. This is we are finding with the iterative approach by using the loop. Here we are finding with the recursive approach by using the recursion. You people tell me please. You people please tell me which code is better from time complexity point of view. Okay, can you please reply in the chat box? Which one is better from the time complexity point of view? From time complexity point of view, which will take less time to execute? Can you write in the chat box? Which will take less time to execute? Can you please write in the chat box? Which will take less time to execute? So one is iterative, one is recursive. So let me tell you one thing. Let me tell you one thing. If you are writing a if you are writing a recursive code, if you are writing a recursive code, then you can write the equivalent iterative code also for that. You can code the same thing by using iteration also, by using loop also. You can write this code by using loop also. Okay. So we just write the Fibonacci, nth Fibonacci number we are finding here. And here also we are finding nth Fibonacci number. So I'm asking the question, okay, which is better? Which will take less time to execute? Jayashri is saying that, let me highlight this. Jayashri is saying that both will take order of n time. Yes. Asymptotically, both are taking same amount of time. One thing we can say this thing. This loop is also executing, see, n time. 2 to n, approximately n time. Okay. Or n minus 1 time you can say. So, and this is already, this is actually also executing. This is how, okay. This is not executing order of n time. This is not executing order of n time. This is not executing order of n time, Jayashri. This is not executing order of n time. How much time? Anybody can tell me how much time this will take? This will not take order of n time. Yes, this is taking order of n time. This is not taking order of n time. How much time this will take? Anybody can check out. Anybody can check out. How much time this will take? How much time this code is taking? This is not taking. Yes, Bharat. Now we get the answer. Now we get the answer. So this is taking actually 2 power n time. This is taking actually 2 power n time. So if you remember, okay, from the third lecture, I shared with you people one recursive. This code I shared, I think, there also with you people. And recurrence relation was something like this: Tn minus 1 plus, okay, again. So this time, okay, this is Tn minus 2 plus constant. So if we will solve this recurrence relation, which belongs to this code, that will take how much time? This will take exponential time, that is 2 power n. Because if you have seen in the previous slide, we build up a complete binary tree, almost a complete binary tree when we were calling the functions. When we were calling the functions for this code, that was building a almost complete tree. And complete tree have how many nodes? 2 power n nodes. How many nodes that have 2 power n nodes? So this code will take 2 power n time. This code will take order of n time. This is taking 2 power n. 2 power n is very, very bigger than n time actually. Why I'm showing this thing to you? Why I'm showing this thing to you? Let me, give me a second. My motive is not to ask you the time complexity actually, not to prove that, okay, this is 2 power n and this is n. My motive is not this. My motive for this slide is that to tell you that we have one misconception. I have seen this in many people actually. That's why I added this slide here also. Many people says that, okay, they think that, okay, recursive codes are always better than the iterative codes in terms of time complexity. In terms of time complexity, this code is taking 2 power n time. This code is taking 2 power n time. This is recursive code to solve the same problem. Fibonacci number. We are finding the nth Fibonacci number. This is also finding the nth Fibonacci number. This is iterative code. Sometimes I have seen that, okay, many people think that, okay, recursive codes are take less time. No, it's not like that. Recursive codes may take I'm using the word may. They may take more time than the iterative code. They may take equal time to the iterative code. Equal or maybe even more than iterative codes. Okay, so it's not like that, okay, recursive codes are better in terms of time complexity. They may not be good in terms of time complexity. Okay, so still why? So why the industry is preferring this, even though this is taking more time? It's not about time. They are okay. they want recursion because this is easy to understand, by the programmer, because it's very difficult to handle the legacy code. Okay, to handle that, if you are writing it in form of recursion, then it's become easy to work on that. Okay, so just one thing I want to show in this slide is that recursive codes may take more time also than the iterative codes. Recursive codes may take more time than the iterative code. So that's why I just added this slide. Space complexity, again, this is taking order of, this is taking again, how much will be the space complexity? This will take order of n space, and this will take constant space. Okay, this code will take constant space. So my motive here is that just to show you that recursive code doesn't mean that okay, they will take less time. They may also take more time than the iterative code. Maybe or may not be. Maybe or may not be. This is the only thing which I want to show you. Fine, okay, fine. Any doubt till now, ask me. Any doubt till now in anything, please ask me. Otherwise, we will now, let's solve one problem from the Facebook. Any doubt till now, ask me. If no doubt, then tell me what is the output for this input, and for this input we already shown over here. Okay, for this and this, okay, what is the output? Any doubt, please write in the comment section. Please write in the comment section if any doubt. Let me erase this thing for me here. Any doubt, you can please ask me. Please clarify that doubt. Durga Prasad is saying that recursion eat brains. Recursion do not eat programmer brain. That eat CPU brain, not programmer one. Maybe in the initial phase that might looking like okay, that is eating our brain. What is the output for example 1, example 2, example 3? Please reply. Karthik was saying, okay, I'm going through the comments now. Karthik was saying that, okay, space complexity is less for iterative approach as compared to recursive. Yes, Karthik, you are right. Space complexity is less. One more thing I can add, okay, if you are comparing if you're really comparing the recursive and iterative, one more thing I can add in this. What is that? The thing is that, okay, even though okay, if I can let's suppose there is an algorithm one which is using recursive approach. I can add one more thing. Okay, this is taking order of n time to solve a problem. There is another approach algorithm you have written, algorithm 2. You are using iterative approach, and that is also taking order of n time. And still, if somebody asks you, which is better, this one and this one, in which is taking more time, like that, which is taking more time. Asymptotically, both are taking same time. Okay, but if you are not talking in term of asymptotic notation, then recursive, this will take more time. Algorithm 1 will take more time than the algorithm 2. Asymptotically, okay, both are taking n time, but if we are not talking in term of asymptotic notation, then this will take more time than this. Why this is happening? Because recursive code is actually, every time in recursive code you are storing the previous function inside the stack. You're storing over here, you are storing again, again. So CPU need to perform this thing also, that need to store the data inside the stack. Okay, that need to store the data inside the stack, and that need to retrieve it. Storing the data and retrieving the data from RAM, that also time consuming, because RAM is very slow as compared to CPU registers and CPU. Okay, so accessing the memory will slow down the process. Okay, so that's why recursive codes are slow as compared to iterative codes. even though asymptotically both are same, both are taking same amount of time, but still if you are removing asymptotic means this word, then if still somebody asking you, you can add one more line that okay, these are taking more time than this because of this whole process, storing the data in memory, function in memory, and taking them back, which you are not doing in the case of iteration. Okay, this is just one another point I'm adding over here. That's it. Okay, fine. So we get some answer output for this one. Let me highlight these. So yes, you are right. So what we are getting, yeah, we are just given, we need to find the power. Okay, we need to raise x power n, we need to find x power n. Okay, so 2 power n is 10, 2 power 10 is actually 1024, and they are giving us in the float, they are giving the number in the form of decimal also, in the float also. Fine, and that will be 2.1 power 3, and that will be something like this, 9.261. So the number can be in the form of float or double. Another thing they give us is that okay, the power can be negative, the power can be negative also. So 2 power minus 2 is what? 2 power minus 2 is 1 by 2 power 2. Okay, and we need to calculate like 1 by 4, and this will be 0.25. So whenever we get this like in negative, whenever okay, we say that if number is less than 0, what we can do, we can to handle this case, what we need to do, just simply we need to say that okay, now the value is here is now 1 upon whatever the value we were receiving earlier. So we will make it just divide by that, and then we can make the number positive. Earlier that was negative, so we make it positive. That's it. So this is the case how we can handle it. Fine. Okay, can you give me the logic why these people are asking this question? These Facebook is asking this question. So let's see why these people are asking this question. First of all, okay, how you will solve this problem? First of all, how you will solve this problem? Can you please reply in the chat box? How you will solve this problem? Any idea coming to your mind? Any idea coming to your mind? Any idea coming to your mind? We get the answer from Vikalp. Fine. Shivam is saying that we will use the math function. I was looking at the meme, one of the meme on LinkedIn yesterday, like interviewer asked, can you please sort these numbers? And the person simply say that, okay, I have sorted the numbers. So he used the sort function and he sorted the numbers. So, okay, that is another good idea means. Okay, Durga Prasad is coming up. Let me take one by one. And Sara and Durga Prasad are talking same thing. They're saying that, okay, sir, this is not a big problem. This is not a big problem. We need to just take the power of x power n, we need to calculate. I will just write a loop. I will just write a loop here. That will start from 1 and that will go up to n. Up to n that will go. And what we will do, we just keep multiplying. What we will do, we will multiplying the I value what we can do, we can take a value, okay, maybe 2 over here, and we are we are take the value of x or 2 actually. X, we can update our x. Okay, directly take, let's take the x, and we can update our x. We can multiply it again and again. We can multiply it again and again. So, okay, n times I need to multiply the x. I need to, x power 2 is what? Okay, n times I need to add the x, sorry. We need to add the x again and again. We need to add it how much time? N number of time, n number of time. What I'm doing? 2 power 5, that is 2 into 2 into 2, multiply. So we are multiplying the x into how many times? N number of time we are multiplying the x. We are multiplying the x n number of time. Okay, fine, fine. Okay, so this is the one thing we can do. One thing we can do. So how much time this is taking? How much time this is taking? This is taking order of n time. This is taking order of n time. So this is very means this looks like very easy. This looks like very easy. Then why these people are asking? Why these people are asking this question if this is that much easy? And the reason is this actually. And the reason is this. And the reason is this. So reason is this. They are expecting the time complexity of log n. They are expecting the time complexity of log n. They want that, okay, can you please solve this problem not in order of n time, but in how much time? Order of log n time. Order of log n time. Can you solve this problem in order of log n time? So any idea coming to your mind how you can solve this problem in order of n time? How you can solve this problem in order of n time? So if you are using the power function, if you are using the power function, okay, math function, that will take actually order of, that will take order of n time. How we will solve this problem? Although the answer is already shared by Vikalp. Okay, fine. So let's try to solve this problem in log n time. Let's try to solve this problem in log n time. So what can be the idea to solve this problem actually? So let's suppose, so this is the idea I'm sharing right now. This is the magic, okay. I'm showing you the magic of recursion actually. And in recursion also actually I'm going to apply a technique that is known as divide and conquer. Divide and conquer actually divide the big problem into smaller problem, then solve it, okay, then conquer it. So that is divide and conquer approach. So we will use the recursion to solve this problem, or you can say that, okay, we will use the divide and conquer. So n values, let's suppose 64. I'm taking some value over here. So if we are finding this value, if we are using our basic approach, then I need to multiply 2 how many times? I need to multiply 2 64 times. So this will take, okay, whatever is the n value, this much time this will take. But we don't want to take this much time. We want to solve this problem into log n time. We want to solve this problem into log n time. So how we can solve? See the magic over here. How we can solve it into log n time? See, we have 2 power 64. We need to find out this value. We need to find 2 power 64. To find 2 power 64, this is the big problem. We know that in recursion, we can divide the big problem into smaller problem. So what we can do, we can divide this problem into 2 sub-problem. I can find out the 2 power 32 and 2 power 32, and I can multiply them. I can multiply them, okay. 2 power 32 into 2 power 32 is 2 power 64. 2 power 64, okay, fine. The powers will be add up when we will multiply. The powers will be add up. Now, again, you are finding that, okay, this is a big problem. 2 power 32 is a big problem. This is difficult to find out. What we can do? we can say that, okay, find out 2 power 16 and 2 power 16 and then multiply them. Then it will be easy. Fine, okay. Again, you are saying that, okay, it's difficult to find out 2 power 16. So take 2 power 8 and 2 power 8. Again, you can divide it into sub-problem. You can reduce it to sub-problem. So you can say that, okay, it's 2 power, is that visible? Okay, 2 power 4 and 2 power 4. Simply keep multiplying them. Again, 2 power 2 and 2 power 2. Again, 2 power 1, 2 power 1 and 2 power 1. Okay, so what we are doing, we are dividing our big problem into smaller problem, smaller problem, smaller problem. Here, you can notice one thing. You can notice one thing. Do I need to calculate this side 2 power 32 again? This is the trick actually. We do not need to calculate this same thing again. We do not need to calculate this same thing again. We do not need to calculate this thing. This we are already calculating over here. 2 power 32 once we are calculating already. What we can do? So let's suppose this value is stored in one temporary variable. So what I can do? I can simply write temp equal to temp into temp. So this second value, we do not need to calculate again. We do not need to calculate. See how many operations we have reduced. How many operations we have reduced. We are not calculating this much big number. We calculated one time only. We calculated it one time. Again, we are saying that, okay, to find out this value, we need to find out 2 power 16 into 2 power 16. So again, these are same. We do not need to calculate 2 power 16 this side. So we just need to calculate this 2 power 16. Again, you are saying, okay, it's okay. Again, let me convert this problem into smaller problem. 2 power 8 into 2 power 8. Again, these two are same. Left and right are same. Do not need to calculate second one. I can just multiply the same value again with the value, same value. You are saying that, okay, let me divide it into further 2 power 4 and 2 power 4. Do not need to calculate 2 power 4. 2 power 2 and 2 power 2. You do not need to calculate 2 power 2. 2 power 1 and 2 power 1. Do not need to calculate 2 power 1 at the right side. Okay. So now what you need to do, just you need to calculate 2 power 1, then you will get the value of 2 power 2. So let me calculate. Here you will get, okay, 2 power 1 and 2 power 1, you will get 2 power 2. 2 power 2 and 2 power 2 you will multiply, you will get 2 power 4, 2 power 8, and then 16, then 32 and 64. So the thing here, what I want to show here is that we are dividing our big problem into smaller problems. One thing. Second thing, this smaller problem is same. This is same over here. So we do not need to calculate it again. We do not need to calculate it again. We do not need to calculate it again. See how many operations we have reduced. How many operations we have reduced. How many operations we have reduced. Okay, one thing. Second thing, okay, can you tell me how much time this will take? See, if we start from 2 power 1 and 2 power 1. So calculating 2 power 1, how much time? Constant time. 2 power 1 is 2. 2 power 1 is 2. Okay. After getting 2 power 1, now we need to multiply 2 power 1 into 2 power 1. So we will get 2 power 2 also. In how much time? Only one operation is done. One operation is done. You will get 2 power 2. After that, again you need to multiply 2 power 2 and 2 power 2. Again, constant time. So you will get 2 power 4. So up from 2 power 4 into 2 power 4, you will get 2 power 8. 2 power 8 into 2 power 8, 2 power 16. Every time what I am saying that, you will take constant time here. Constant here. Constant. Why? Just one multiplication. One statement you are executing. This one. One statement you are executing. You start from this. Finding 2 power 1 is again constant. After that you multiply them, you get the 2 power 2. Again, to get 2 power 4, you need to just perform one multiplication. This statement you need to execute. And you will get 2 power 4. To get 2 power 8, again one statement need to execute. 2 power 4 into 2 power 4. And you will get 2 power 8. So every time you are taking constant time, just one multiplication you are performing. One multiplication. Okay. And how many multiplications you have performed? Let me count, okay, directly. Let me count and see how much time this code is taking to execute. Let me count directly. From this number itself, let me try to count. So 1 multiplication, 2, 3, 4, 5, 6 multiplication I have done here. Okay, 6. And you can notice that, okay, log of this n, log of 64 base 2 is how much? 6. Log of 64 is how much? 6. So how much time this will take now to find out 2 power 64? Log n time. That will take log n time. You can check out this thing by divide operator also. We have already discussed that. Okay, whenever you're dividing the number by 2, what will be the time complexity? Every time 64, 32, 32, 16, then 16 divided by 2, 8, then 4, then 2, then 1. So how much time this will take whenever you use the divide? Log n time. How much time? Log n. So anyway, you can means check out how much is the time complexity for this logic? Log n time. So what is the logic? Okay, I'm repeating again. What is the logic? The logic here is that we need to calculate 2 power 64. So one way is that I multiply 2 64 times. That will take n time. I need to multiply 2. So that will be, we will get 2 power 64. One idea is that, but that is taking order of n time. And these people are asking us to solve this problem in log n time. So what we can do? We can use the recursion, and we actually using here divide and conquer approach, in which we are dividing our big problem into smaller problem. And because smaller problems are same here, so we do not need to solve it again. Whatever value we will get from here, we will multiply it to itself. Temp equal to temp into temp. So we will multiply this value. That's it. So again, you are saying this value is bigger. So let's make it smaller. And every time you just need to perform one multiplication actually. So constant time every time you need to perform to get the bigger value. And how many multiplications you need to perform? Log n. You can see how much time you are taking. Log n time. That's it. So we can solve this problem. We can find the power of a number in how much time? In log n time. Okay, fine. I hope this is clear to you people. Any doubt you can ask me. And if we want to code it, how we will code it? Very easy actually. So let me erase it directly. How we will code it? Very easy. Let's suppose that this is the function we are calling, in which we are passing x and n, x power n. We need to calculate. Then what we need to do? Just divide this number every time. Okay, we can call this function again and again. Recursively we can call it. X passed as it is, n will be divided by 2 every time. N will be divided by 2. That's it. Keep calling it again and again and again and again. And when you reach from 64 to 32, 32 to 16, 16 to 8, 8 to 4, 4 to 2. Okay, and then maybe at 1. Okay, you can write a termination condition. Let me write termination condition. So when n equal to 1, then you can return this value x. You can return this value. Okay, and after doing this, we know that when we reach to the last term, we need to multiply it to itself. So what we can do is, we can take a temp, okay, and we can multiply it to itself. So store the value from here, whatever value we are getting every time, just we need to multiply it to itself. That's it. That's it actually. This is the main idea. Little bit more things we need to add in this. What can be the more thing? Like what about if I need to calculate 2 power 65? Let's suppose n value is 65. Then what we need to do? So in that case actually, this will work like this. 2 power 32 into 2. One more 2. 2 power 32 into 2 power 32 is 64 into 2, 65. This is going now same way. 2 power 16, 2 power 16, 2 power 8, 2 power 8. So one more 2 you need to multiply. Okay, when this is actually odd, I can say. Okay, so what you can do, you can add little bit more code here to cover up this case. We can say that if you can say that, okay, if temp is if temp not temp actually, if n if n is equal to if temp if n mode 2, I'm checking if this is even or not. If this is even, then we do not need to do anything. If this is 64, we do not need to do anything. Just simply return the temp. Whatever value we get, return it. Else, if this is odd, then what we need to do? Simply multiply this temp with x, means with 2. X value is 2 here. Multiply it, then return. So this is the one case you need to add, one more extra case you need to add. If we have odd value, for that one, if else you can write. If that is even number, simply return, we will get the value. If that is odd, then you need to multiply. Then you need to multiply with that to cover up that case. Okay, so that's it actually. One more case actually will also occur here, that will be related to if the power is negative. If the power is negative, what you need to do? Simply divide the number with 1. Divide that with 1. Okay, because here 2 power minus 2 is what? You can say that, okay, that is 1 upon 2 power 2. So simply divide that with 1, with that number. So some cases extra you need to add. Otherwise, this is the main idea. The main idea lying here in these two statements. The main idea is lying in these two statements. Okay, let's try to code it. Then more clarity will come. Let's try to code it. More clarity will come. I will repeat the same thing. So let me erase it. Let me try to code it, and we will see the same thing. How many people are able to get this? Okay, please, can you please reply in the chat box? I just want to know. Okay, it's not the end. Let me go to the browser, and here is the problem. Here is the problem. Same problem, I pick it from here, and let's try to code it actually. So fine. So what we can do? Okay, let me call this function my POW. This function recursively again. So what I can do? Okay, let me take this. I will do the same thing. I will take a temporary variable, and I will call this function my POW. I will call this function recursively x comma n divided by 2. So this is what we talk. We're just dividing the n every time by 2. After dividing it, when we will divide it until what? We need base condition. If I can say that, okay, when n will be equal to, okay, when that will be 0. When n is 0, then 2 power 0 is 1. So return 1. We can return 1. Fine. So this is a termination condition we can add. And after that, we just need to multiply our temp 2 times. Temp equal to temp into temp. We do not need to calculate the temp 2 times. This is the trick. We need to multiply. We can multiply it. We do not need to calculate it second time. Once, because both are same. Left and right both are same. After doing this, okay, we add one more condition that, okay, for even and odd, if n is even or odd, n is even or odd. If that is odd, we need to multiply it one more time with the x. So let me write, if n mod 2 is equal to 0, means that is even. If that is even, just simply return the temp. Return temp. Otherwise, if that is odd, else. If that is odd, then return, simply multiply it with the x. One more time we need to multiply because that is odd. Okay, this case is done, this is done. One case we need for this negative number. One case is if we get the negative number, then simply we will put it into the 1 divide by 1 we will do. If I can say if n is less than 0, if n is less than 0, then what we need to do, just say x is equal to 1 upon x. So okay, this is in a floating point, so I'm writing 1.0 upon x. Divide it with x and make the n now positive. Make the n now positive. So I can write, I make the n positive. That's it. So we cover this negative power case also over here, and this is the base condition. Okay, and this is the main thing we are doing. That's it. And this part is handling if the n is even or odd. That's it. And if we run this code, let's see, that is accepted. Let me submit it. This is accepted. So that's it. This is what we discussed. This is what we discussed. Okay, one more thing in this, let me add. For the okay, this code is same for the Java also. Let me copy it and let me go here in Java. Let me paste over here. I think this will work fine. Yeah, it's working fine. The same code is working in Java. Fine. And if you are a Python programmer, then the same code is written over here, same logic. This is a termination condition. This is for negative numbers. Okay, and this is the main logic, and this is for even and odd handling. Fine. I hope this thing is clear to you people. I hope this code is clear to you people. Any doubt you can ask me in this. Okay, Durga Prasad, you are asking for if we are making the power in the fractions. So here actually, in that case, okay, we need to modify then the code little bit. There is another versions of this question also. There is this is the first version I have taken because this is the foundation course. So I just take the foundation problem here. But there is other versions also where Durga Prasad we can experiment over there. So check out those one, and you will we can solve those problems means related to this. So right now, okay, let's keep it little simple, and let's keep it an integer itself. Okay, there is another question from Karthik. Karthik is asking, let me read the question. Variable in the function will also be stored in stack, or only address reference of the function is stored in the context switching? Okay, so variable will also be stored. Karthik, variable will also be stored. Karthik, variable will also be stored. All the temporary variable will store. All the temporary data will store. All the temporary data will store. Actually, the same registers need to be used by the other function also. Same register need to be, registers are limited, CPU registers are limited. So same registers will be used for calculations again. So you need to store the temporary data. Fine. Any other question related to this? Otherwise, okay, that's it for today. It's done now. Okay, and any doubt you can ask me, or anything also we can discuss. So my motive for this session was, okay, I hope you get the idea of, if first time you were watching this, My motive was that okay, you get the idea of recursion, how the functions are calling to each other, and how we can write the code with the help of recursion. How means very basic examples I try to took here, like printing 1 to n, and again we are modifying the code from printing n to 1, like 5 to 1. Again we are modifying the same code to sum up the numbers. So the motive was just to that okay, you modify the code and you start using the recursion. You're using the recursion to solve different problems. You start using the problem, you are start using that to solve different problems. Okay, so that more will be come from practice only, no doubt, but just I was trying to give you the idea of the recursion. And after that okay, we solve one problem also, that was Facebook problem itself. You can find little more tougher versions of this problem, um, which I do not took here. That will be requiring little more practice. Okay, that will be requiring little more practice, but these can be done. Just I want to show you that okay, this problem can be solved. This is not that much tough. This is not that much tough. If we will do practice, then this will become easy for us. Okay, then thank you everyone. If you like this session, if you get information from this session, please like it, and please mention it in the comment section, so that that can be reached to maximum students. That is my target actually, so that that must reach to maximum student actually. Okay, otherwise okay, thank you everyone. Good night, bye bye Shivam, bye. Thank you Shivam, Mandeep, Shyam, Mohan, everybody, Karthik, bye bye, take care. The background image some of the recursion. So how this is summing up the recursion. Okay, Durga Prasad, we need you actually. I need the people who can create some humor here, so that people feel don't feel bored actually. Thank you JR, thank you everyone, bye bye. I'm ending the session now.